Hello everyone, welcome to my YouTube channel. Today we discuss on the topic de-Broglie hypothesis and matter waves. It is basically bridging the gap between particle and wave. So let's start with a questions that if light which we thought was a wave can behave like a particle, or the can matter or which that we think like a particle can behave like a wave. At the beginning of 20th century, the light can behave as a light. We proved that or seen that it is a wave, and it is well established and proved by Maxwell's theory, and that matter is a particle, that is well accepted and proved in Newtonian mechanics. There are Newton's laws of motion, but experiments such as photoelectric effect, which is explained by Albert Einstein, prove that light behaves like a particle. He shows that particles, those are in the form of photons. So this wave particle duality of light lead to a revolutionary idea proposed in 1924 by scientist Louis de-Broglie. So with his name it came as a de-Broglie hypothesis. So his proposed is all moving particle possess like wave particle properties. This idea became a pillar of quantum mechanics. So today will we explore what is de Broglie hypothesis, why this concept came, and what is the mathematical wavelength we got from the de Broglie hypothesis. Myself Anima Ghosh, I am associate professor of physics. So we'll be starting today with the point of view that what are the limitation of limitation of classical physics, and where we start, or we may say that birth of quantum theory. So we know that classical physics provides the fundamentals of all particles properties, from their velocity position measurement. So classical physics basically the foundation for understanding many physical phenomena at microscopic scale. It very accurately describes the motion of object, the behavior of the projectiles, and the other system visible to the naked eye. So classical physics operates, or classical physics is on the is established, or it is on stand under the assumption that initial conditions like positions, velocity, etc. of a system are known. Its future behavior can be precisely predicted. Example, let's say the trajectory of a projectile or orbit of a planet. So deterministic laws that everyday objects follow precise laws with definite position. So a matter treat strictly as a particle, electrons or protons. So the fundamental theories like Newton's laws of motion, it govern the dynamics of object under force. Lagrangian mechanics. So here we seen that reformulas of Newton's law using energy functions useful in bit complex systems. Hamiltonian mechanics. So here we see that the center of modern physics, especially in transition to the quantum mechanics, harmonic oscillator. In case of harmonic oscillator, that mass on a spring central to understand the vibration and the waves. Also the planetary motions that explain the Newton's laws of gravitation and conservations of laws. So these are the well established and can be explained very well from the classical point of view. We may say that classical mechanics or Newtonian mechanics. But classical mechanics is there have some limitation, like it fails to explain that as physics progressed into the microscopic domain, several experimental observations could not explain well by classical theory, like the stability of the atoms. That this is a structure we can see that we know that in atomic scale the atoms are very stable with the nucleus and the electrons, or we cannot see that in an atom the electrons are means they are in a particular orbit they can round. There is no shown that classical electrodynamics suggests that the orbital electrons or orbiting electrons should continuously radiate energy and spiral into the nucleus. However, we have seen that atoms are very stable. In addition to that, like hydrogen spectrum, that classical physics predicts that it is a continuous spectra, but hydrogen emits the, we know it, that like discrete spectral lines, and this discrimination implies the quantization beyond classical explanation. And near light speed in relativistic velocities also we have seen intense gravitational field, extreme space time distortion, and one more important which we have discussed in my previous YouTube lecture, the photoelectric effect, that in classical theory predicts that the light energy building up over time regardless of frequency. But experimentally it observed that electrons are emitted instantaneously. Emission only occurs above a threshold frequency, means minimum threshold frequency is required for emission, and intensity affects the number, not the energy of emitted electron. So these results are incompatible with the wave theory, but explain very well with the Einstein's using the photons. Also, we have seen the similar failure to explain in the Compton's effect, that classical wave theory fails to explain the change in wavelength. So, wavelength of the X-ray scattered by electrons. The effect supported the particle nature of light. So, and also one more important, very famous phenomenon, that is black body radiation. That classical theory leads to the ultraviolet cathode strobe, but predicting the infinite energy emissions at shorter wavelength. So scientist Planck resolved this by introducing the energy quantization. So in this regards, this some failures of the classical physics in atomic and subatomic realms, like in a very microscopic object, small atomic level, pave the way for the quantum approach or quantum mechanics. So a revolutionary framework that incorporate probabilistic interpretation and quantization of energy. So will we explore now that what is this radical phenomenon or proposal of the de Broglie hypothesis. So today we will discuss on that the de Broglie hypothesis. So we know that there are evidence that light is a wave. Let's say we know the interference. If we talk about the diffraction, if we talk about polarization, young double slit experiment that we have studied in our school level, that these phenomena cannot be explained by particle theory alone. So here a detailed explanation or a clarification required, like for interference, that we know that interference is a phenomenon in which two or more coherent light waves supposed to produce regions of constructive or destructive intensity. So we got the constructive interference, which we usually call as bright fringes, and destructive interference we generally call it is a dark fringes. So why this particle theory fails, that if light were just particle, that two beams crossing should simply add intensity. This would not be like alternate bright or dark fringes. So if we talk about the diffraction, that diffraction is nothing but it is the bending or spreading of light wave when they pass through a narrow slit or around a obstacle. So it observed that when light passes through a small aperture comparable to a wavelength, is spread out, or if we talk about a diffraction pattern, that we see in the diffraction pattern we generally see with a central bright maxima, and then some other fringes is formed. So here the clarification is missing, that if light are particle, then they would travel in a straight line. They would produce a sharp shadow. There will be no spreading or fringe pattern would occur. So diffraction is purely a wave property. So same applicable or this understanding for the polarization. That polarization, we know that this is the phenomenon in which the vibration of light are restricted in one direction. So only transverse wave can be polarized. Since light shows polarization, light must be a transverse wave. So this particle theory fails to give the answer that particles have no concept of vibration direction. Polarization cannot be explained if light is only particle. So this interference, diffraction, polarization, these are the clearly demonstrating that light can behave as a wave. So if it behave like a wave, so it requires a superposition principles, shows a wave spreading, and it demonstrates the transverse wave. So they cannot be explained by classical theory alone. Evidence like light as a particle, we have discussed that photoelectric effect, Compton effect. So the if waves or light can behave like a particle, perhaps particle can behave like wave. So light can behave a particle, and matter can behave like a wave. So this symmetry inspired scientist de Broglie, and his radical proposal is proposed in 1924, that Louis de Broglie extended the wave particle dualism from light to material particles. The logic behind is that nature loves symmetry. If light can act as a particle, then matter should exhibit wave particle behavior. So he gives the definition of the matter waves, that the wave associated with a moving particle is known as de-Broglie wave or matter wave. So if we say de-Broglie wave, the matter wave, both are the same thing. So here the main concept is that not only light but every materialistic particle like electron, proton, even heavier object, these all will be having the wave particle nature. So with these observations that establish a form relations of wave length with the particle mm, mm, physical that quantities like mass, velocity, momentum. So the famous de Broglie hypothesis, from de Broglie hypothesis, the famous formula which connect both dual properties or wave particle duality nature, that is nothing but the wavelength lambda is equal to h, which is the Planck's constant, divided by mv, that is lambda is equal to h divided by P. So this is the very fundamental formula, or this is we may say the main pillar of quantum mechanics. So here we can see that this wavelength lambda, this is basically the defining the, if we have a wave, then we generally define it representing by the wavelength or frequency. So this is representing the wave nature identification, and this h by mv, m is the mass and v is the velocity. So these are the, like if we have a particle having some mass and velocity, that means its particle physical properties is showing, so it is incorporating both wave and particle behavior. So this is the famous formula of de Broglie hypothesis. This is known as de Broglie wavelength, and so we can see from here that the faster or heavier particle, the shorter is the wavelength. So there are some important implication of the matter wave, that microscopic particle like electron have noticeable wavelength, and for macroscopic object obviously the wavelength is so small that it is undetectable. So now will we see that how we can define this wavelength in terms of kinetic energy or some other useful forms. So will we look on that. So before that this is the importance in quantum mechanics. Why? Now this is the first concept or first revolutionary concept that introduced the wave particle duality for matter. This is laid the foundation of Schrödinger wave equations. So you can find the Schrödinger wave equation step by step explanation, and it is derived in my channel in previous lectures, and it is the essential in quantum confinement, electron microscope, quantum well, and semiconductor physics. So this hypothesis united the particle and wave behavior under a single framework. So this formula basically signifying the formula, it is just this is very simple formula, but this is very meaningful and important formula, that this brings the particle and wave behavior under a same framework, and it was experimentally verified and transformed an understanding for microscopic world. So division and German experiment is one of the famous experiment to verify this hypothesis. So in I'll be in some of my lecture I'll be come with this division German experiment. So let's move forward that how this formula we can write in terms of kinetic energy. We know this kinetic energy, that we can write this kinetic energy half of mv square, that is in the form of p. So here also we can derive that. So the kinetic energy relation, we know that kinetic energy is basically half of it is basically the half of mv square. So just we consider that if we consider that p is equal to mv, then we can find out the p is equal to root over twice me. We can get this formula. So just it is substitute in lambda is equal to, we know that lambda is equal to, we seen that it is basically lambda is equal to h divided by p. So then we can just substitute this p is equal to root over twice me. Here E is the kinetic energy. So we can find the relation between wavelength in terms of kinetic energy is this. So we can also find out this de Broglie wavelength, this formula, in terms of the accelerated electron. So if we see that this is an accelerated electron and having a potential V, so if an electron is accelerated through a potential difference of V, then kinetic energy is equal to basically work done, which is nothing but EV. So we can write this formula again, lambda is equal to, we know that wavelength in terms of kinetic energy is lambda is equal to h by twice me. H divided by twice me. So this kinetic energy E is basically the work done for the case when the electron is accelerated through potential difference V. Then we can write H is equal to root over twice MeV. So you know the charge of the electron is 1.6 into 10 power of minus 19, and so mass of the electron is 9.1 in 10 power of minus 31. So if we use these two values, we can find out more shorter that this formula. We can write this is equal to that de Broglie wavelength in terms of accelerated potential, that lambda is equal to 12.26 divided by root V. So that you can write it that 12.26 divided by root V Armstrong. So this we can write that de Broglie wavelength in terms of accelerated potential. Now let us back that it is not a light, something new. So we know that electromagnetic wave, which is defining by this basically that electromagnetic wave. So here our matter wave are not electromagnetic. It is not the electromagnetic. They are probability wave associated with moving matters. So this is defined as matter wave, or we can say pilot wave, that independent of charge. So now there are some properties of this wave visibility. So the wave that from the formula itself, lambda is equal to h by p. So you can see that, which is again depending on the mass into momentum is basically the mass into velocity. So if the higher mass is too higher, then it will be more high, then lambda will be close to 0, and if it is the small low mass particle, then we can find it the observable wavelength. So this means that for microscopic particle we can easily find out the de Broglie wavelength, but for a macroscopic particle, that it is not predictable for the wavelength, that will be very small. So matter wave exists only in motion. So if the velocity is 0, that case wavelength will be infinity. So here the formula is, if we see that v is equal to 0, lambda will be infinity. So this means the matter wave exists only in motions. So we can see that lighter particle, longer wavelength, slower velocity, longer wavelength. The critical condition is if v is equal to 0, that case lambda is equal to. So the key point is matter waves are associated only with moving particle. So now let us summarize the qualitative toolkits from de Broglie wavelength to use in our scientific place. So these are the formulas to keep in notes. So it will be useful for exam, it will be useful for solving the problems and to understand the phenomenon. So in terms of momentum, the lambda is equal to h by mv, which is nothing but h by p. In terms of kinetic energy, lambda is equal to h divided by root over twice me. In case of accelerated charge particle, the lambda is equal to h divided by twice me. So this also can be write as, if we just use the value of Planck's constant h, that we know that Planck's constant value we know, that is basically h is equal to 6.625 into 10 power of minus 34 unit is joule second. And for electron, this charge, that is basically 1.6 into 10 power of minus 19 coulomb. Mass of the electron m, that is basically 9.1 into 10 power of minus 31 kg. So important here point is that whenever we solve it, that it is better to convert all the units in SI units to consider so easily. So if we use this, we can get the lambda is equal to 12.27 divided by root v Armstrong. So these are shortcuts, that if we find that accelerated electron accelerated potential is given, so one can easily find out by this shortcut the de Broglie wavelength. So let us check some exercise. So I hope these are the formulas and this concept will be useful for you. So stay tuned for more updates, and if you like the lectures, please like it and subscribe my channel. So will we next focus on our exercise. So first exercise, that in case of a proton. So here it is given that de Broglie wavelength lambda is given as 2 angstrom. So first is our task is that we have to convert the what is given here. So here it is given here the lambda is equal to 2 angstrom. So it is always a good habit to convert all units what that it always in the same units to find out. So if let us convert this 2 electron angstrom to in the form of meter. So we can find it 2 into 10 power of minus 10 meter, and we know the mass of the proton, that is mp. So that we know, that is basically 1.67 into 10 power of 27 kg, and we know the Planck's constant, that 6.626 into 10 power of minus 34, and we know our de Broglie wavelength formula, that is lambda is equal to h by p. So since here given is lambda, we can just rewrite it, p is equal to h divided by lambda. So if we use in this formula, then one can find out that p is equal to 0.3 into 10 power of minus 23 kg and meter per second. So now second step, that since we have the, this is kg meter per second because it is momentum. So the kinetic energy formula, we know kinetic energy K is equal to p square divided by we know that kinetic energy K is equal to p square divided by 2m. So you use the what we find out the momentum, then one can easily find out that kinetic energy is equal to 0.329 into 10 power of minus 19 joule. So now it asks that calculate its kinetic energy in electron volt. So we have our formula, we have find out in SI unit, that is in joule. So from joules to electron volt, 1 electron volt is equal to that 1 electron volt, that 1 EV, that is 1.6 1. Minus 19 joule. So we can convert it, and then one can find out the kinetic energy E, that is basically 0.206 eV. So this is the one example with for the proton, the finding the de Broglie wavelength. Let us consider the another example with electrons and accelerated potential. So let us consider this problem, that electron is accelerated from the rest through a potential difference of V is 100. Calculate its de Broglie wavelength. So you know the formula in shortcut, that is lambda is equal to 12.27 divided by root V angstrom. So here V is given 100 volt. So just substitute in place of V 100 volt. One can easily find out the wavelength lambda is equal to 0.87 angstrom. So the final value for the electron accelerated in a race through a potential difference V is equal to 100 de Broglie wavelength lambda, that is equal to 0.87 angstrom. So now let us summarize our today's lecture, that we have started the concept for the first hypothesis, that de Broglie hypothesis says us that all matter exhibit wave-like behavior, and it bridges the gaps of classical and quantum, that with a single formula it can gives the lambda is equal to h by p. This small formula, basically it is a very fundamental and important significant formula which connect the particle and the wave worlds, and that implementation is lighter and slower, the mass wavelength will be the more, and it is reverse. So this is the introduction, and this is the main concept, means pillar of the quantum mechanics. So it is important to remember that matter exhibit wave particle duality, that is wave particle duality. Then de Broglie wavelength lambda is equal to h by p, and it is well connected, or it can be right in terms of kinetic energy, it can be right in terms of accelerated potential, and significantly only for microscopic particle. Microscopic particle, it is experimentally verified, and it is the main basis for the Schrödinger equations. So there are some concept questions that to the audience that you may type me in, or you can send me in the chat box of my YouTube channel. I'll be very happy to discuss and happy to connect with you, that why do not we observe wave nature of humans? What happens if the to the wavelength if the velocity increases? Also the questions come that can stationary particle have wavelength, and why this de Broglie hypothesis is revolutionary. So I hope you enjoy and like the video. If you like the video, please click the like button, and if you want more similar lectures of me, then subscribe my channel. Thank you very much. Thank you.